Okay, so we're doing synthetic division now of polynomials, which we're going to like a lot better. It's faster, it's easier, it's just better. Okay, so we're going to take the problem. We have the polynomial p of x cubed minus 57x plus 56. We're going to divide it by the divisor d of x minus a. Noticing that x minus a, we're going to divide it by x minus 7. Noticing that our divisor is always in the linear form x minus a, so it's x minus 7. What do we notice about this polynomial? It is of degree 3. We are missing something of degree 2. That's going to be important for us. Now, let's start with the process. The first thing we do is eliminate the variables and the exponents. So let's just write the coefficients of the polynomial. The coefficients are 1, negative 57, and I meant to write 56. So let's write 56 there. So, and 56. So let's write our coefficients. When I write my coefficients, I write 1. And then if I have no x squared term, I must include a 0. So there must be some place mark for every degree. So nothing for x squared, so I write a 0. Then a negative 57, make sure you have your sign this way. Now what I need to do is I need to decide what I'm going to divide by. I want to divide by x minus 7. So I see here it's x minus a. So what I'm going to divide by is whatever is opposite to that factor. So if what I'm going to divide by is what looks like 7. If I had x plus 7 here, then I would actually divide by a negative 7 here. So this is in the form, as we're very familiar with, x minus the variable. Remember, change the h, keep the k. X minus a variable. So this is actually x minus a positive 7. So we're going to divide by the positive 7. Okay, so now let's start with the process. The process goes like this. Bring down the first number. Now we're going to multiply 7 times 1. And we're going to place that number here. And then we're going to add. 0 plus 7 is 7. And we're going to start the process all over. 7 times 7, 49. And we're going to add. Now this is a negative plus a positive, so that is going to be a net negative 8. And we're going to start it over again. 7 times negative 8 is negative 56. Add, we get a net 0. So you see that synthetic division is such an easy process. And now we're at the end. We've come to the end, so what we do is, with synthetic division, is we block off the last number, whatever it is. In this case, we have our last number is a 0. This number, whatever it is the remainder. Now that is very significant, because if the remainder is 0, if the remainder is 0, then if the remainder is 0, then d of x, whatever we divided by, which in our case was x minus 7, and q of x, which is our answer, are factors. Okay? Are factors. Are factors. So let's see what we have for q of x. We know it's a factor, so let's look at it. We have 1, 7, and negative 8. Well, what does that mean? So now we have to take what's in synthetic form and translate it back into a polynomial. We start over here at the right and translate it. This is in the lowest degree, so this is just negative 8. This is 1 degree higher, so 7x, and this is a positive 7, and this is the next degree higher up, which is x squared. So this answer to p of x divided by d of x is x squared plus 7x minus 8. This is q of x, or our quotient. Now we could, now that it's just in a simple quadratic, it's easy for us, we could easily factor it now. So let's see if we could factor this. We have negative 8, a times c is negative 8. What multiplies to negative 8 but adds to positive 7? Positive 7. Well, 1 and 8 are factors of 8. If one of them has to be negative in order to get to negative 8. So if we make the 1 negative and the 8 positive, then that would add to 7. That would add to positive 7. So that would give us x minus 1 and x plus 8. So we can, if you can get a polynomial down to a simple quadratic, it's often you're able to factor it. So now we know what all the factors of our original polynomial are. We know that the d of x is a factor. We know that q of x is a factor, which we can now easily factor. So our three factors are x minus 1, x plus 8, and x plus 7 are all factors of the polynomial p of x. This, however, is the point we really want to remember. I'm going to restate that one more time. If the remainder is 0, then d of x and q of x are factors. And the opposite is also true. If the remainder is not 0, then d of x and q of x are not factors. Okay.